Okay, so this is going to be a support video for the review we were working on today. Just kind of gives you a little bit of extra support for it. So let's see here. Let's see if we can get this thing to. All right, so again, this is a little bit easier for us to work with right here, where we know that there's a property of exponents that says if I have x to the m times some number, same basis, x to the n, we have x to the m plus n. So we said this right here was going to be x to the 7th when we're adding 2 plus 5. Okay, next we have 3x to the 4th. So again, this 4th power applies to the 3, and it also applies to the 4. So we have 3 to the 4th power times x to the 4th power. Well, 3 to the 4th power is 81, and then we have x to the 4th. When we look at this one, we see here that 4 to the negative 4th is the same thing as 1 over 4 to the positive 4th, and we still have this 4 squared here. So when we multiply this, we have 4 squared over 4 to the 4th power. Now, going back to our properties of exponents, if we have some number x raised to the m power, and that same number x raised to the n power, then that's the same thing as x to the m minus n. So when we apply this over here, we have the same bases for each one. So we can say 4 to the 2 minus 4 power, which gives us 4 to the negative 2 power. This can further be simplified as 1 over 4 to the positive 2 power, which is equal to 1 over 16. Okay, same property applies with the division. We have the same bases here. So then we're going to subtract the exponents. So we have x to the 8 minus 17, which is equal to x to the negative 9, which is equal to 1 over x to the positive 9th power. Okay, next we have this right here. And again, this is no different. This 5th power applies to the numerator and the denominator. In simpler forms, if I was to just write 2 over 3 raised to the 3rd power, well, that's the same thing as saying 2 over 3 to the 3rd, which is equal to 8 over 27. So we really don't do anything different for this right here. We say t to the 3rd power being raised to the 5th power. Then we have z to the 4th power, and that is being raised also to the 5th power. Now, we apply a principle here in this part that says that if we have some number x and it's raised to the m power, then also raised to the n power, a power to a power, then we have x to the m times n. So we're going to apply that by saying t to the 3 times 5 over z to the 4 times 5, which is t to the 15 over z to the 20. And that's it. Next, our complicated one. Okay? So let's kind of just break this down. We're going to do this in small chunks. Okay? So we know that this right here, if I have some base x raised to the negative n, that's the same thing as 1 over x to the positive n. This base can be a number or it can be a collection of variables and exponents. So then this is going to be the same as 1 over e to the 4th g raised to the positive 3rd power. Now again, this power gets distributed. So now we have 1 over e to the 4th, which is raised to the 3rd, and we have g to the 3rd. Again, further using our exponential properties, now we have 1 over e to the 12th, g to the 3rd. Okay? That takes care of this part. Now let's deal with this part. So we'll use a different color for that. All right. So again, let's just go ahead and apply our exponent to each one of these terms. So it's rewritten as 3 to the third. Then we have e to the third. Then we have f to the negative fourth, but that's raised to the third. Then we have g squared, and that is also raised to the third. So then we have 27, 3 to the third is 27, e cubed, f to the negative 12, g to the 6th. Okay? But again, this f to the negative 12 is the same as 1 over f to the positive 12. And again, we still have 27, e cubed, g to the 6th. So when we multiply all of this together, we get 27 e cubed g to the 6th over f to the 12. Now when we multiply this to this, we're going to take this whole thing right here and we're going to move it. So we're going to rewrite that as 27 e cubed g to the 6th over f to the 12th times 1 over e to the 12th g cubed. So when we multiply this all together, we get 27 e to the third g to the 6th over f to the 12th e to the 12th g to the third. We're not done yet though, because we can group these together. All right? So this is the same thing now as saying 27 over f to the 12th times e to the third over e to the 12th times g to the 6th over g to the third. I'll give myself just a little bit more room here now. Now again, to go ahead and apply my properties, this is the same as e to the 3 minus 12 and g to the 6 minus 3, which gives me e to the negative 9, which gives me 1 over e to the 9th. Clean that up a little bit. Okay? G to the 6 minus 3 is just g to the third. So we have g to the third here. And then we have this, we bring this all the way down, and we have 27 f to the 12th. So we multiply all this together, we have 27 times 1 times g to the third is 27 g to the third over f to the 12th times e to the 9th is f to the 12th g. I'm sorry, e to the 9th. And that would be my answer. We just have to take it in small pieces at a time. Not try and get overwhelmed. We're using the same rules. It's algebra. We're using the same rules. We're just using them repeatedly to make our way through a more difficult problem. Okay? Anything to the 0 power is always 1. We're looking for what number p is equal to, where we would get x to the 24. So x to the 6th, if we were to raise that to the 4th power, we get x to the 6 times 4, which is x to the 24th power. Okay? X to the f over x to the 2, if we were to replace this f with 11, then we would have x to the 11 minus 2, which would give me x to the 9. Okay? So again, one of the rules that we talked about before is that if we have x to the m over n, that is the same thing as the nth root of x to the m power. So when we look at this, this is our index, this is our exponent. So if we rewrote this, we're saying the third root of 2 squared would be the third root of 4. And that does not equal the square root of 32. Okay, we decided to go ahead and skip the radicals. We're going to deal with that on Monday, quiz it on Tuesday. Same thing with scientific notation. We're going to move that to Monday, review it, quiz it on Tuesday. Okay, so the rules of a polynomial, you need to look in the chapter for that and study what makes a polynomial a polynomial. Okay? If it's going to be a polynomial, I'm looking at my exponents. My exponents cannot be negative or a fraction. So when we write this in standard form, because the degree of this monomial is 3, the degree of this monomial is 1, the degree of this monomial is 2, and the degree of that monomial is 0, when I put it in order, we have 4x cubed minus x squared minus 2x plus 1. Now, when we go back to the table we had looked at before, if we have one term, it's a monomial. And again, this is in your book and you need to study that table. It's 2 terms, it's a binomial. 3 terms is a trinomial. And anything after 3 terms, we just call it a polynomial. Okay? So because this has got 1, 2, 3, 4 terms, it's considered a polynomial by the terms, and the highest degree is a 3. So we call this, because of the 3 exponent, we call this a cubic polynomial. Okay? This is not a polynomial because of my negative exponent, so therefore it's no. However, if I had a positive exponent, because I have my highest degree is 5, when I wrote it in standard form, it would be negative 2x to the 5th plus 4x to the 4th plus 3x. Because I have a power of 5, we call it a quintic. And because I have 3 terms, trinomial. Quintic trinomial. Okay, adding polynomials. All we're doing here is because we're subtracting them. I like going ahead and just distributing this negative. So we have minus 3x to the 4th plus x squared plus 7. And then we have this 2x squared plus 2x to the 4th plus 5. So my like terms, I have a 2x to the 4th and a negative 3x to the 4th. So I have a negative x to the 4th. We can cancel these out. We have a 2x squared plus an x squared, which gives me a 3x squared. And then we have a 5 and a 7, which is plus 12. That's my answer. Okay. These are a little bit easier, so for sake of time, I'm going to go ahead and skip these and go straight to FOIL. Okay? So FOIL, first, outer, inner, last. So take our first terms. 4x times 3x is 12x squared. Then we take our outer terms. Well, 4x times 3 is 12x. Then we take our inner terms. 4 times 3x is 12x. Finally, we take our last terms. 4 times 3 is 12. When I combine like terms, 12x and 12x is 24x. And then we bring the 12x squared and the 12 down. This is my answer. Okay? If we use that as an example, we should be able to navigate through the next. Now, FOIL, again, works when we are multiplying a binomial times a binomial. However, if we are multiplying a binomial by a trinomial, we don't use FOIL. We can't. All right? So, this is no different than just applying the distributive property. We are taking this number right here and multiplying, or this binomial right here, and we're distributing it to each one of these terms. Okay? So we can realistically just rewrite what we have right here. We have 8m squared plus 2m minus 1. And now after we distribute the m minus 2, it's just multiplying each term by m minus 2. All right? So now we can go ahead and simplify. 8m squared times m is 8m cubed. 8m squared times negative 2 is negative 16m squared. 2m times m is 2m squared. 2m times negative 2 is negative 4m. Negative 1 times m is negative 1m. Negative 1 times negative 2 is positive 2. Now I collect my like terms. Well, I don't have any other m cubed. Negative 16m squared plus 2m squared is negative 14m squared. Negative 4m minus 1m is negative 5m. And then we don't have any other constants. And this is my answer. Okay? This is the same thing as FOIL. We're foiling this right here, but in this case we have two variables. We don't do anything different than what we've done before. First, well, 6x times 5x is 30x squared. Outer, 6x times negative y is negative 6xy. Inner, 5y times 5x is 25xy. And then the last 5y times negative y is negative 5y squared. Well, we have like terms. Negative 6xy plus 25xy is 19xy. Okay, so combine the like terms, 19xy, and then we have this 30 Let's do that in red, make sure we're consistent. We have the 30x squared, and then we have the negative 5y squared. And this is my answer right here. Okay? Again, you can use that same example and try this one. Okay, if you were going to get the answer to this, the answer would be 16m squared minus 30mn plus 9m squared. See if you can do that on your own and come up with that answer. And that's it. If you have any questions, I'll be here early in the morning. I can go ahead and help you out with any problems you have.